So section 3.1, and every bit of chapter 3 is graphing, okay? The first section is about graphing linear inequalities. Now you graph some linear equations. We're going to take those linear equations and we're going to turn them into graphs of linear inequalities. So just some quick information to get started. Linear inequalities have a lot of realistic applications. One of the things that we're going to do with this is called linear programming, and the purpose of linear programming is to optimize something. Like, for example, your profit, or to minimize something, say your cost. So it's a very, very useful idea. And one of the realistic problems that I'm giving you here to start with, if the factory can manufacture no more than 12 items, whatever that item is, on a shift, then you need to be able to use an inequality to solve that. If a medical researcher must be sure to interview at least 100 patients, then you have to have a linear inequality to make sure to solve for the correct number of patients, so that they'll have a treatment for a disease to see if it's better than the old treatment, because they need 100 people to make sure, or at least 100 people to make sure they have enough information. So this is where we're going to begin. How can a company determine the feasible number of units of each product to manufacture in order to meet all of their production requirements? This is going to be a problem we're going to look at. And to solve this, we're going to have to solve a linear inequality. And notice here that this is not in the form y equals mx plus b. Okay? This is not y equals mx plus b. It is in the standard form where you have ax plus by equals c. Only in this case, your equal sign has been replaced by an inequality sign. Either equal to or less than, equal to or greater than, less than or greater than. The only way to solve this kind of problems that we're going to do in this chapter is to solve them graphically. You can solve a single linear inequality algebraically. There's a few little tricks you have to remember about trading signs now and then. But we're not interested in the solution to a single linear inequality. We're going to be looking at these in pairs or threes. So here's what we're going to be faced with to begin with. We want to graph the linear inequality 2x minus 3y is equal to or less than 12. At this point, I'm going to shift over to the overhead instead, so that we can graph this. And I want my calculator handy to help me with it. That's a little bit bigger than I wanted, a little awkward, so I'm going to shrink it down. Well, I need it. And if you want to prepare your calculator, just go ahead and turn it on, clear the home screen, and then go to your y equals menu and clear that screen, and then we'll go from there. So we're going to graph the linear inequality, and we can graph it on the calculator as I showed you. But I'm also going to remind you that you can find some quick points and be able to graph it that way. So we're going to start off finding the quick points. First step in graphing a linear inequality is to graph the equation. And if you've got your chapter 3 warm-up, you probably have a graph of this equation on that warm-up on the very first graph. So if I'm going to graph that, one, I need to find the x-intercept. I can use the calculator to find it, but I'm also going to use arithmetic this time just to make sure everybody understands there's two ways to do it. The x-intercept means you let y equal 0. So 2x minus 3 times 0 equals 12.
Should you put the equals in and then just change it back later?
Change it back later. So right now we're graphing, this is actually called the boundary. The equation is called the boundary. So if I have 3 times 0, that's 0, and 2x minus 0 is still 2x, and 2x equals 12. If I divide both sides by 2, gives me x equals 6. And that gives me the point 6, 0. So then my second step would be to find the y-intercept. And that means I'm going to let x equal 0. So I have 2x, only x is equal to 0, minus 3y equals 12. And 2 times 0 is 0, and 0 minus 3y is still negative 3y equals 12. Divide both sides by negative 3. And y is equal to negative 4. So that gives me the point 0, negative 4. And then I need a graph of that equation. So I'm going to draw an x and y axis. And I'm going to plot the point 6, 0. And the point 0, negative 4. And then this is the thing that is peculiar to graphing inequalities. So you look back at your inequality sign. If your inequality sign includes an equal sign, then that means you're going to graph a solid line. And we're going to see something a little different when we do the next one. But because this one says equal to or less than, I'm going to graph a solid line. So you graph your line. And you label the equation of the line, and that's 2x minus 3y equals 12. So thus far we haven't really learned anything new. We could have done that day one. Now here's the new part. We need to find which side of that line contains solutions to that inequality. So what we're going to do is we're going to pick 2 points. On this first one, I'm going to have you pick 2 points. And I'm going to let y'all choose the points. Somebody choose me a point up here. Anywhere up here you want.
0, 0.
Okay. I bet I know why you picked that one too. That's my favorite point. Okay, so we choose 0, 0. Now somebody choose a point down here. On this side of the line.
Negative 6, 1.
Okay. Negative 6, 1 or 1, negative 6? Because negative 6, 1 is going to be up here.
It would be negative 0, negative 6.
0, -6 works, that's fine. Okay, so here's the point 0, -6. Okay, now the key is to pick points on both sides of the line. Now eventually, we're going to work down to a process where you're only going to have to pick one side, and if one side works, then you know the answer to the other side. But I want to show you this time what happens on the two sides. If I choose the point 0, -6, and I go back to the original inequality statement, 2x minus 3y is equal to or less than 12, and I substitute in 0, -6, that's 2 times 0 minus 3 times -6, and my question is that equal to or less than 12? So 2 times 0 is 0, minus 3 times -6 is minus 18, which is then positive 18, because you're subtracting negative 18. Is 18 equal to or less than 12? No, it's not. So that means you do not shade. You do not shade that side of the line. Because what that ultimately means is that there are no solutions anywhere down here. No point that I pick on this side of the line will solve the inequality. So then I'll test the point 0, 0. And I like 0, 0 because 0, 0 I'm not really likely to make a math mistake, so that's 2 times 0 minus 3 times 0. Is that equal to or less than 12? Yes. 0 is certainly equal to or less than 12. That means that any point on that side of the line satisfies the inequality. So this one didn't, this one did. And that means that when I get ready to shade, you may want to get yourself a couple of highlighters for this chapter. When I get ready to shade, I'm going to shade on this side. So the solution to the inequality is here. I can't show it to you any other way. You have to graph to see the solution to the inequality. Okay? Now your calculator, I'm going to tell you up front, your calculator will shade inequalities for you. But you have to go through a bunch of algebra to get it set up to where you can put it in the calculator and then make sure that you got all of your signs right and your inequality sign correct before it's going to shade the correct side. If you don't tell it the right information, it may not graph the right line and it may not shade the correct side. So in this particular instance, you're going to do these by yourself. You're going to use a test point just like I did. You can use the calculator to check that your equation is right. You can use it to find your x and y intercepts. But you're going to need to be able to do these shaded areas yourself by testing a point. Okay? So let's try another one. So my second one is graph the linear inequality x minus 4y is greater than 4. Get that as high as I can so we'll have plenty of room to work. I think I'm just going to get the calculator out of the way for the moment. So we're going to do the same sort of steps that we did on the last one. First thing we're going to do is we're going to graph the boundary. That means you're going to graph the related equation. And when we graph that equation, the quickest way to graph it and get it the most certain way to be correct is to find the x-intercept, which means we're going to let y equal 0. And we find that x is equal to 4. So that gives us the point 4, 0. And we're going to find the y-intercept. That means we're going to let x be 0. And that means y is going to be -1. So that gives us the point 0, -1. So we use that information to draw the boundary. Plot the point 4, 0, 0, -1. And this time what's going to change is we're going to go back and look at this inequality, and we're going to see that that inequality says greater than, and it only says greater than. There is no equals. So when we graph the boundary, we're going to graph a dashed line. What that means is the boundary is not included in the solution. And the problem we just did above that, the boundary was included in the solution, but in this one the boundary is not included. So we show that by making a dotted line or a dashed line. So this is the line x minus 4y equals 4. And it has a y-intercept of 0, -1. And an x-intercept of 4, 0. So then step 2 is the test point. So we're going to choose a point on either side. Somebody choose me a point from down here.
0, -2.
Okay, 0, -2. Now somebody choose me a point from the other side.
0,
0, 0. Why does everybody choose 0, 0? Why do you like 0, 0? I think I know.
Makes it easy.
It makes the math easier, that's right. So I'm going to test this one first by plugging into the inequality. Zero minus 4 times -2. Is that greater than 4? Okay, 0 minus 4 times -2 is plus 8. Is 8 greater than 4? Yes. That means we're going to shade on this side. But just to be sure, we're going to take x minus 4y is greater than 4, and we're going to try out 0, 0 just to be sure. 0 minus 4 times 0 is greater than 4. That's 0 minus 0, which is 0 greater than 4? And the answer is no. So that's no shading. Okay? That means that my shaded area needs to include the one that I answered yes to, which is this point. So that means I'll shade on this side. So the solution to that inequality is here. So that means the solution, this area solves the inequality, x minus 4y is greater than 4. Just like the solution here represents the solution to 2x minus 3y is equal to or less than 12. Okay? Does anybody have any questions on either one of those? Now, if you can do this, you can do this whole chapter. No problem. Okay? So let's keep moving forward. In the PowerPoint, and I'm going to post the PowerPoint, it sends you to the tutorial, and I'll go back to the PowerPoint and show you where that tutorial takes you because the link is supposed to be live. Okay, apparently it's not, so I will copy and paste and I'll show you where this takes you. Come on. I don't know if I can do this or not. Okay, there we go. So where it takes you is to a graphing calculator tutorial that's actually part of your My Math Lab.
Is that where you want us to go?
I want you to be sure that you understand where this is.
It's in the tools for success.
It's in the Tools for Success.
Which one is,
It says Graphing Calculator Tutorial on it.
and then,
We get into My Math Lab.
which one? Graphing?
Mm-hmm.
And there's a bunch of them.
Yeah, there's a lot of them in here, but we want to find, I want to show you which one I want you to use because this is the best one. They're all good, but the one I'm going to show you is the best one. It's this one right here. And it opens up in a new window. Okay? So it's under Technology and Support, and it's the next to the last one. Use the Graphing Calculator tutorial to learn basic TI calculator functions. Now the thing that's going to help you with this is going to be to choose graphing. This is in the PowerPoint. So choose graphing. And then it opens up a menu, and if you'll go all the way down to the bottom, it will show you how to graph a single inequality and shading. And it basically just says go to your y equals menu, and
It says shading a system of inequalities. Am I in the right one?
right. You're in the right
Graphing
place.
a single inequality.
Graphing a single inequality
And shading. That's the
okay?
one you want us to know?
Yes. Yes.
All right.
So you press your y equals, and we're going to graph 2x minus 1. And we're going to hit graph, or we're going to hit zoom 6 to see the graph. and it shows us the equation. And now the shading part means you have to go back to your y equals, and you're going to have to press your left arrow key until you get all the way over here on the edge. Now you can press enter from there, and this, come on, press enter. I think there's, okay, it's really slow. And that makes it actually shade. And I can show you even better on here than what the tutorial does, because this is bigger. But the tutorial will help you. It steps you through it. So doing the same thing on the TI-83 that I've got up here, I'm going to graph 2x minus 1, zoom 6 for the standard window.
What is it, 2x minus 1?
Yes.
And then do what? Hit zoom?
Zoom and then the number 6 button. And you should be here. Okay? Then press your y equals. Move your arrow over in front of y1. And if you'll watch while you're pressing enter on the calculator, it looks different. That first one is going to make it have a really thick, heavy line. That one says shade above this line. Notice it shades the upper half of the box.
What do we do when we get here and it's blinking right there?
You move it over in front of, or let me make sure that is, let me see where you are again.
See how it's moving?
Yeah, press your enter key. Keep pressing your enter key until it shows you the bottom part that's shaded here. It should take about 3 times. Okay? So it's shading below the line. We want it to shade below this line. And then you press enter. I'm sorry.
Oh,
You don't press enter, you press graph. That's my bad.
okay, so how do I get it back?
Just keep hitting enter and it'll keep cycling through it. So when it blinks with the little
Oh,
triangle,
you can be a dotted line too.
yeah, you can do all kinds of lines. Once you get the way you want it, then you just hit graph again. So your calculator will do the shading. But now think through what all you'd have to do to be able to get it to do this. You've got to first solve your equation for y. Then you've got to figure out on your own, like we just did already, which side of the line do I want to shade on. Then you have to go back to the y equals and tell it how to, which part to shade. Do you want me to shade below the line or do you want me to shade above the line? But the calculator will help you. The reason this actually is kind of a good thing, though, is because when we're graphing a system of inequalities, it'll show you how to do 2 of them at once. But you still have to do the work I'm showing you how to do. So on that same page in your notes, I just saw.
Did I do it?
Yes, you did it right. That's exactly right. On that same page in your notes, this is a summary of the steps that you go through. So if you need, a place to put a star, this is how you do it step by step. This is what you want. Now, we're going to move from there, and it's not really much different what we're going to do next. We're going to solve a system of inequalities. Just like equations can come in systems, inequalities can come in systems. And what we're going to do is we're going to kind of work at the same process. First thing we're going to do is we're going to graph y equals negative 3x plus 12. Now, since handily this one has already been solved for y, we can graph this one more easily using the slope-intercept method. So this tells us that the y-intercept is 0, 12, only because it's y equals mx plus b. Okay? So the point 0, 12 is on the line, And we also know by looking at this that the slope is -3 over +1. So the way we use that information to our advantage is we draw our graph grid. And we know the point 012 is on that inequality in that equation. So 012, the only way I'm going to get 012 on here is to count these as being 2 each. So this is going to be -2, -4, -6, -8, -10, -12. And then I'm going to use my slope and say if I go down 3,
It's a positive 12.
oh, thank you, thank you, thank you, thank you. Let me get a clean sheet of graph paper here, so I don't mess up further. And actually, a good thing about this one is that I can adjust it to be bigger if I needed to. So I'm going to go 0, 12, and the slope is going to be -3 over 1. So I'm going to go up 2, 4, 6, 8, 10, 12. And then my slope says count down 3 and write 1. 1, wait, now this is, I'm sorry.
By 2.
This is by 2, so this is 2, 3. So I'm going to go 1.5 blocks and then write, now I'm going to count these as 1. These are counted as 2s. 2, 4, 6, 8, 10, 12, 14. 2, 4, 6, 8, 10. But these are going to be 1s. 1, 2, 3, 4, 5. So I'm going to go down 3, but I'm going to go right 1. And then I'm going to go down 3 and right 1. And down 3 and right 1. And down 3 and right 1. And I'll have plenty of points by using the slope and the y-intercept to draw my line. Now, I need to look back at my inequality. My inequality said y is less than -3x plus 12. So should I make a solid line or a dotted line?
Dotted.
Make it dotted because there's no equals in this. Just a less than. I'm going to make a dashed line. And that dashed line represents y equals -3x plus 12. Then I need to choose my test point. And your favorite test point is 0, 0. Okay. So we'll test 0, 0. 0 is less than -3 times 0 plus 12. Is 0 less than 12?
Yes.
Yes. So I'm going to shade on the side that has 0, 0.
The answers that are on the dotted line don't count.
The answers that are on the dotted line don't count, that's right. So then we're going to move to the other inequality, and the next inequality is x is less than 2y. Now that one's not going to be easy to necessarily put in the calculator, but we can. We just have to do some algebra first. Start out with your related equation, x equals 2y, and we'd like to solve that for y, so we can put it in the calculator if we wanted to, or to make it easier to graph. So that means we're going to need to divide both sides by 2, or multiply both sides by 1/2. So 1/2 times 2 is 1. That means I have just y on this side. And that means y is equal to 1/2 x. And if y is equal to 1/2 x, I know that the number that I could put out here and not change that would be 0. And that tells me that its y-intercept is 0, 0. And it tells me the slope then is up 1 and right 2. So I'm going to go to the point 0, 0, and I'm going to go up 1. Remember, this is 2, so I'm going to go up 1 and right 2. And then up 1 and right 2. And then up 1 and right. Let's see. That's 1 right. That should have been right there. So then I'm going to go up 1 and right 1, 2. Or I could just as easily have gone down 1 and left 2. That just means I'm going negative and negative. And since this one also is less than, I'm going to make a dashed line. Now, I need a test point. But can I use my old buddy 0, 0? If I use 0, 0, is it on one side or the other of the line, or is it on the line? It's on the line. So I can't use 0, 0. I've got to pick something else. Somebody pick me an easy point to test.
0, -1.
0, -1. Okay. There's 0, -1. I'm going to test that point. And I'm going to test it in x is less than 2y. Don't ever go back to anything you did over here. Go back to the original. So x is 0 and y is -1. 0 less than 2 times -1 is -2. Is 0 less than -2? No. So that's no shading. Now, if you're not sure, then pick a point on the other side and plug in. You know, pick out like 1, 1. Okay? And you'll find that it does work. But now I'm going to have to shade the solution to the second inequality. And since it doesn't include this, I'm going to go in the other direction. Now, all of that orange solves x minus 2y, or x is less than 2y. And all of this yellow solves y is less than negative 3x plus 12. But where's the only place that there's solutions to both of them? The place where they're both shaded. So the solution to both of them together is right here. It's where the shading overlaps.
Is that the only part we have to shade? We have to shade
Yes.
everything?
After this, I'm going to show you a way that you can not have to do so much shading and shade just the part you want. Okay? But the idea here is that this is where they overlap. You have to shade the part where they overlap. Okay? So that is the solution. To the inequalities, the two of them together. Just like you have a solution to a system of equations, you have a solution to a system of inequalities, but unlike with a system of equations where the solution might be a point, or it might be an expression, depending on whether or not there may not be a solution at all. In this case, it's the overlap of some regions. So we need to get a little terminology out of the way here. Oops, went too far. The region consisting of the overlapping parts of two or more graphs of inequalities in a system, such as the heavily shaded region in this example we just looked at, is called the feasible region. And the reason it's called that is because it's made up of all the points that satisfy or are feasible for all the inequalities of the system. So that's what a feasible region is. So let's graph the feasible region for the next set of inequalities. So our set of inequalities is y equals negative 2x plus 8. And I think I'm going to put my axis over here on the side. And I'll explain why here in a second. The reason I'm doing that is because I'm looking ahead at the second inequality, and it says x is between negative 2 and 1. I think I already messed up, so I'm going to get a big sheet graph paper. Doesn't realize I drew my axis in a bad place. So we're graphing y is equal to or less than negative 2x plus 8. And then we're also going to graph negative 2 is equal to or less than x is equal to or less than positive 1. This is going to be easier than you think it is. There's my XY axis.
Where should we do them on this little graph one here? I went ahead and did it the other way you have. Should we put them in the middle?
Just put it in the middle. Or draw it on one of the other two lines. You could put it, instead of where I have it here,
Yeah.
this.
Put it in the middle.
You can put it on this first one here, and it'll still work. There's not a right or a wrong way to do it. I just realized I messed up there, and I wanted to keep it all clean for y'all. So y equals negative 2x plus 8. That means I'm going to go to 0, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to use the slope, which is negative 2, so I'm going to go down 1, 2, and right 1. And down 1, 2, and right 1. And 1, 2, and right 1. And 1, 2, and right 1. And because it's equal to or less than, I'm going to make it solid. And then I need to test a point. And our favorite point to test is always 0, 0, if we can use it. So 0 is equal to or less than negative 2 times 0 plus 8. 0 or less than 0 plus 8. 0 is equal to or less than 8 is true. And that tells me that I want to shade toward 0, 0.
On the test, do we have to do a testing point for every line? Is that when we have, like, take points off, we don't do a testing?
Yes. Yes, you're going to have to do a test point.
Okay.
Now, rather than go ahead and start shading, since I know that I've got this other one that I'm going to have to shade too, and I don't want to have to look for double shading, what I'm going to do is I'm going to make myself a little note here and say I need to shade toward 0 by drawing just some little arrows. Say, go to that side. Okay? Now, this, like I said, is easier than you think it is. One thing I want you to remember, and you're going to need to know this throughout all the rest of the math that you know, when you have what's called a compound inequality, the arrows always have to point left. You are never going to have that say negative 2 is equal to or greater than x is equal to or greater than something. You always start.
You've got negative 2 less than or equal. The equal should not be there. Does that change things? Because I'm
It will,
confused
I
about
mean-
the solid and dotted line on that.
Okay, yes, it does. Thank you. That one does have an equals, the other one doesn't. So this one is just less than.
Line on that one.
Okay. We're going to use 2 lines, actually. The first line we're going to use is negative 2 equals x. We're going to ignore this part. We're going to do negative 2 is equal to x. But when we draw the line, it's going to be dotted because that's a less than sign. So we know that x equals negative 2 is a vertical line that goes through the point 0, negative 2.
Now, do we have to, or we put the equation on there for that line?
Do we have to shade?
No, I've already marked it. Go ahead, I'll figure it out.
Okay. Now, we're going to ignore this part. We're only going to look at x is equal to 1. We know that's also a vertical line through the point 0, 1. This time it's a solid line because it says equal to or less than. And when you got one like this, you don't need a test point, although you could use it. This is X, and it's between those two numbers. So for that reason, the shading is between those two lines. You need to learn to read this as X is between -2 and 1. And this is where X is between those two lines. Okay? So looking at only what's between these two lines and the fact that we want to be below that blue line, that tells us that the feasible region is only the part that's below this, but it's everything else in between these lines. And that way we didn't have to do a lot of extra shading. So that yellow area is the solution to this entire system. Okay? Any questions? Now, so that we can get to an application of this, I'm going to skip over the next two examples and come back to them. But what I would like for you to do if we don't get finished with them today, and we should get finished with them today, but just in case we don't, I want you to go back and finish those and come back to me. I'll make some suggestions, but I want to get to this application problem because it shows you why are we doing all this? What good is this? So for our application problem, we have Happy Ice Cream Cone Company makes cake cones and sugar cones. Both of them have to be processed in the mixing department and the baking department. You can make one batch of cake cones, requires 1 hour in the mixing department, 2 hours in the baking department. Then it says producing one batch of sugar cones requires 2 hours in the mixing department and 1 hour in the baking department. And each department is operated at most 12 hours a day. So we've got our table like we had in the last chapter. We're going to let the cake cones be X, the sugar cones are going to be Y. So we know that the cake cones take 1 hour in the mixing department and 2 hours in the baking department. And the sugar cones take mixing department and 1 hour in the baking department. And when you add all the hours together for the mixing department, it can't be more than 12. And when you add all the hours together for the baking department, it can't be more than 12. And that gives you your system of inequalities to start with. Now there's actually 2 more parts to this system. Why is it important that we have X is equal to or greater than 0 and Y is equal to or greater than 0? Why do X and Y need to only be positive?
Because you can't have a negative amount.
That's right, you can't have a negative amount of mixing time, you can't have a negative amount of baking time. So that tells us when we get ready to draw our graph here that it doesn't make any sense to include anything negative on X or Y. So we're going to be in quadrant 1. Most application problems, most every problem we're going to do that's not just a graphing example is going to be in quadrant 1. So most of your application problems are going to be always in quadrant 1. Now remember, X is your number of cake, and Y is your sugar cones. So what we need to do is we need to graph X plus 2Y is equal to or less than 12. And I'm going to do it by finding the intercepts. If I let X be 0,
Which one are you on here? X plus 2y?
the first one, X plus 2Y is equal to or less than 12, but I'm using equals 12. If I let X be 0, I can just actually cover up X and say 2Y equals 12. So that's the point 0. Let's see, if 2Y is 12, Y is equal to 6. And then if I let Y be 0, that means X is equal to 12. So there's my two intercepts, 0, 6, and 12, 0. And since it's equal to or less than, then I'm going to make my line solid. And then I'm going to go ahead and graph the other, these are called constraints. Your inequalities are called your constraints. So for my 2x plus y is equal to 12, if I cover up x, that means y is equal to 12. So that's 0, 12. If I cover up the y, that means 2x is equal to 12. And then x is equal to 6. So I have 6, 0. And I have 0, 12. And again, that's an equals to, so I'm going to make my line solid. So the blue line represents the mixing department. And my red line represents the baking. And what I want now is I want the solution to that system of inequalities. And my favorite test point is always which one? 0, 0. So if I test 0, 0, and I have 2x plus y equals 12, only it's equal to or less than 12, this says 0 is equal to or less than 12. Is that true?
Yes.
Yes. So then if I test it in the mixing equation or inequality, x plus 2y is equal to or less than 12. 0, again, is equal to or less than 12, so of course, yes, that's true too. So that means I'm going to go below the blue line, but I'm also going to go below the red line. And then what that will have in common is that little odd-shaped corner down in here. So this is my feasible region. So there's the solution to my system of inequalities. Now we need to answer some questions. It says, using the graph, can you make 3 batches of cake cones and 2 batches of sugar cones? And if you look at your axes, Y is your sugar and X is your cake. So this is actually asking about the point, where is 3, 2 on that graph?
In your area.
And it's in your feasible area, because if you go 1, 2, 3 cake cones, and then go up 1, 2 sugar cones, that's this point right here. So is it feasible to make that? The answer is yes. So yes, it's in the feasible region. So then the next question they ask us is, can 4 batches of cake cones and 6 batches of sugar cones be manufactured? Well, that will be over here. Here's 4 cake. Then I need to go up 1, 2, 3, 4, 5, 6 sugar cones. And the answer is no. So you say they cannot make 4 batches of sugar cones and 6 cake cones. I'm sorry, cake and then sugar. I wrote it backwards. So they can't make that, but up here, yes. They can make 3 cake and 2 sugar. Okay? So that's where we're headed with all of this. Now backing up to the 2 that I left you with, I don't want you to bring these in so we can check them next time, because this is the only ones we haven't done. I want you to remember that what you need to do here to address this is keep your graph to the first quadrant. Okay? That's not necessarily true here, but when you make this one, remember that's going to be a solid line, but it's going to be horizontal. Concentrate on these 2 first and then add that one. Okay? And we'll check those beginning class next time and then go on to section 2.
Are those going to be great, or just kind of checking and see if we get it right?
I want you to check it to see if you get it right. And then your homework, you have 2 problems to do for your turn problems. Those are in Shogun. Okay?
For 3-1.
For 3-1. So we're ready to do 3-2 when I see you next week. Chapter 3 is a short chapter. You'll have another test coming up pretty quickly.
Hours tomorrow or later today to discuss this.